Hello everyone, welcome to the course Manufacturing Processes. This is a video lecture series, already you know. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So first we will start with what we discussed in the last class. We started with the course, means why we are doing this course, and then we saw what is the definition of manufacturing. In that we saw many aspects are there, what is raw material, how it is being processed, and how it will be converted into final product. Then we saw what is the meaning of processing, and we saw in that processing is not only to change the dimension of the material, but also to add the extra feature which will be required according to the application. Then we classify the manufacturing processes, and we saw broadly it is classified in three parts. That during the process, if the material remains constant, means whatever the material we have used at the starting, if it is same after the processing, so it was zero manufacturing, we gave the name. And then if there is deposition of the material, means the material mass or the weight is more as compared to what it was initially before the processing, then it will be positive manufacturing. And third was also there, that is known as negative manufacturing. So what will happen during the processing or the manufacturing, some of the mass or the weight of the material will be lost. Best example is machining. So we saw the classification of manufacturing also. Now today we will start with the casting process, that is the first process in this series. We will see what casting is, what is the importance of this, what are the major applications. Then we will see what are the terminologies of the casting. So we are starting with the casting process. So this is probably the oldest manufacturing process. Why I am telling oldest manufacturing process? If we will look at the history, in world history, it has been given that it started in 5000 BC. 5000 BC. That's why it is considered at the oldest. In India history, it was started in 3000 BC. The first cast product was found in Mohenjo-daro, and it was a dancing girl, okay, which was in 3000 BC. That's why it is called as the oldest manufacturing process. So what is the principle of this process, or we can say what are the steps which are being followed during the processing or during the casting process? So 5 total steps are there. It starts with the cavity. Cavity means first we will have to manufacture the cavity or the hole where we have to pour the molten metal. So that will be decided what will be the dimension of the hole, what will be the internal part, or what will be the shape. All these things will be decided on the basis of what is the part that we are going to produce or cast. Okay, so first we will prepare the cavity. To prepare the mold or mold cavity, different materials are used. Sand may be used, metal may be used, wood may be used. So it totally depend upon the application, the amount of product that we are going to produce during the casting. Second step is, as we have to pour the molten metal, so whatever material we are going to cast, we will have to melt that, and for that different type of furnaces will be used. So that metal will be melted over there in a crucible, and then from that crucible it will be poured inside the mold cavity that already we have created. In third step it will be poured, okay, and fourth step we will leave that molten metal over there in the cavity for some time for solidification. Once it will be solidified over there, so in the last step we have to remove that. If it is sand mold, of course we have to break the mold, and then we will take out product. We take out our product from that mold cavity or from the sand mold, okay. And finally whatever the gating system or accessories are over there with the casting, we will trim that, and finally we will get our product. So these are the total 5 steps which are followed generally during the casting process. One by one we will see all these things in detail once we will come in lecture of based on this casting, okay. So next we will see what are the major applications of this casting process. Some of the important applications here given in diagram as well as in this text form, but these are not the only applications where casting is used. Probably 50 to 60% of the part today we are producing will be produced by the casting process. So it has enormous amount of application in almost every field of manufacturing, but some of the important I have quoted here in this slide. So we will start with the machine tool structure. It doesn't matter what kind of machine it is, generally the structure, especially the base, is made up of casting. The reason is, whenever we will do the machining, during the machining vibration is the major issue. So if we will not dump that vibration, there will be problem. So dimensional inaccuracy may occur during the machining. So to overcome, generally the base of the structure, whatever the machine we are using is of cast material. So first application is machine tool structure. Then motor casing is generally prepared by casting. You can see here in the diagram. Then V6 engine, this is also prepared by the casting process. Engine blocks are used, crank shaft, railway wagon wheel components are, impellers which is used in pump is also manufactured by these, nozzles, dumbbell, all these things are prepared by the casting process. As I said, these are the some of the important applications. Many other applications are there where casting is used. So why casting is used? That is a big question. Question will come in mind. So what are the advantages of the process? As I told 50 to 60% till now in the manufacturing, casting is used. So now automatically question will come in mind, why casting is used extensively in all the manufacturing processes. So these are the some of the points. After going through this, it will be clear why casting is used almost in 50 to 60% of the manufacturing sector. So first advantage of this process is it can produce intricate shapes, intricate or complex shape. Why it can produce intricate or complex shape? The reason is, as we know, in casting, first we have to melt the metal, whatever metal we are going to cast. That molten metal we have to pour inside the mold cavity. So if you are pouring inside the mold cavity, as we know, it is in liquid form. So liquid has the characteristics or beauty of the liquid is it can easily flow. So when it has property of flow, so it can reach even the intricate part or the very constricted area. Once it will reach over there, then obviously it can produce the part, because once it will reach over there, it will solidify over there and it will take the shape, whatever shape we are going to produce. So this is the beauty of this process, that even the complex shape, which is very, very difficult to produce by other processes, other manufacturing processes, can be produced with the help of casting if you are using casting process. So complex geometry or intricate shape easily can be produced by casting process. Second application is it has flexibility in the sense of size and weight. Even the small ornaments or jewelry that can be produced with the casting, and even the whole body of a car or any kind of vehicle can be produced by the casting. If we talk about quantitative data, so even in grams you can produce the product, and even you can go in tons of weight you can produce. So we can see how bigger the range of this process is. Even the small component you can produce, and even the larger component you can produce by casting. That's why it is highly flexible. That is, its range is very, very high in case of, if we consider the dimension as well as the weight. This is the second advantage of this process. Third advantage is it is very, very simple and also inexpensive. If I am telling simple, that means even the non-trained workers can easily use this process to produce the part. It is inexpensive if we are using sand as a molding material. We know sand is very, very inexpensive material. It is easily available, cost is not very high. Okay, so it is inexpensive if we are doing sand casting, and also for that we don't need a skilled worker, we don't need any sophisticated instrument to carry out this process. So it is simple and inexpensive. That is the third application of this process. Fourth one is any material can be cast. What is the meaning of any material? We can cast ferrous material as well as non-ferrous material. So all the material available, almost all the engineering materials can be cast by this process, which is not possible by all the processes. For example, if we are taking welding or other manufacturing processes, or even the metal forming processes we are taking, always there will be problem of different kind of problems will be there. But the beauty of this process is, here we just have to melt the material, and for melting we have to take the material temperature up to its melting temperature. Once it will be in molten phase, after that we just have to pour inside the mold cavity where it will be solidified. So that is the reason it is extensively used, that all the materials easily can be cast without any problem. Okay. Fifth advantage of this process is wastage is very, very less. And if you remember, in the first lecture of this course, I told during the classification, this comes under zero manufacturing process. Means here there will be no loss of the material. Of course, gating system or the accessories will be there when we will do the manufacturing, when we will do the casting process, but those will be trimmed and again can be melted and used for production of other product. So if you will see overall, there will be no loss in the material, there will be no loss in the mass. So whatever the mass was initially, suppose you are taking MI, the initial mass or the weight of the material which is used for casting, and what is the final mass, whatever product we are getting, always these two will be same. That's why it is also known as zero manufacturing. So practically there is no loss in the material. Again I am repeating, whatever the accessories or whatever the parts or the gating system will be with the cast product, that will be trimmed in final stage, and then trimmed part with, it may be riser, it may be runner, it may be a sprue, it may be pouring basin, all these parts will be again remelted and again it may be used for the other production of other cast product. So overall if you will see, there is no loss in the material. So ultimately or finally if you will see, there is no loss in the material. That's why this is known as zero manufacturing. So wastage is almost zero in this process, and probably the most important advantage of this process is, this is the only alternative for certain materials. What is the meaning of certain materials? Some materials, for example tungsten carbide, it is very hard, which is very difficult to process by other processing process. So if you are processing these kind of materials, it is very difficult to process, but this is not the case with the casting. If we have to cast tungsten carbide, we know we just have to reach at its melting temperature in a furnace. Once it will reach over there, after that we have the cavity or we have the mold cavity where we just have to pour the material. So this is the beauty of this process. Even the material which are very difficult to process by other processes, in the case of hardness or reactivity or other problems, easily we can handle with the help of casting. So these are the major advantages of this process, and because of that, as I told earlier, 50 to 60% till now of the manufacturing processes or whatever products we are producing, in which casting is used. But we know every process in this world, everything has pros and cons. This has also some disadvantages, and these are the three disadvantages I have listed here. First one is, if we talk about the sand casting, so of course it is labor extensive. Labor extensive means many number of labor are needed over there to carry out the process. Why many hours of work will be needed over there? Because sand, what we are getting from the market, that will have a lot of impurities mixed with that, so that we need to remove. Also the size of all the sand particles will not be same, so to bring it in of equal size, we will have to crush that. Okay, and after crushing we will have to use some sieving operation to sieve all the sand particles. After that we have to prepare the sand mold, so we will have to mix water, we will have to mix some additive, so that sand mold will be prepared. So that's why this is, if we are using sand casting, so it is called as, this is labor extensive, means more hour you need to prepare or you need to carry out the process. And second problem is dimensional accuracy. Okay, so always there will be dimensional inaccuracy in this process. This is not accuracy, this is inaccuracy actually. So this dimensional inaccuracy always will be. What is the reason for that? In the principle of this process, we saw molten metal which is in liquid state, we are pouring in mold cavity. So what is happening here? Here there is phase change. Material is changing its phase from liquid to solid, and we know whenever there will be phase change of a material, always there will be either contraction in the dimension or elongation in the dimension. Okay, so here also it happens. We are pouring molten metal in mold cavity where it is solidifying. Okay, so during solidification, what will happen? Always there will be contraction in the dimension, there will be reduction in the volume of the material, that need to take care. That is the reason dimensional inaccuracy is inevitable almost in this process. So this is the another disadvantage of this process. And the last disadvantage is surface finish. It doesn't matter how sophisticated the casting process we are using, whatever the process is, always some surface roughness will be there, which is generally removed by the machining operation. So these are the three disadvantages of this process which are associated with the casting process. Next we will see what are the important terms or what are the terminologies or what are the terms which is generally used in the casting process. So it starts with the flask. We will see what is the meaning of flask. Then pattern is there, parting line is there, molding sand, facing sand, then the core, pouring basin, a sprue, runner, gate, chaplets, enriser. These are some important terms which are repeatedly will be used in this course in the casting process. Other terms are also there, but that will not be used frequently, but these are some important terms which will be used repeatedly during the study of this course. That's why I have taken. So one by one we will see what is the meaning of all these terms. So first one is flask. It is nothing but a molding box. For example, suppose we are taking sand molding. Okay, so we have to prepare the sand. So sand mold is prepared, sand will be there, generally silica is taken as a sand, then water will be there and some additive will be there. So proportion of these three will be divided, that is the standard value depending upon what kind of material we are going to cast. So depending upon the material we are going to cast, proportion of these three, silica, what the sand we are using, what is the water content over there, and the third one is what is the additive that we are using over there, like clay. So this proportion of these three will be decided, and then we will prepare this mold. Okay, so we have to put this inside a box. So whatever the box we are going to use, this is known as flask or this is known as molding box. So here you can see in diagram, it is quite clear. Now this flask may be made up of any material. It may be made up of wood. Here in the diagram you can see it is made up of wood. It may be metal also depending upon the application. Okay, so it may have one part. If a single piece pattern is used, it may have two parts. If a split pattern is used, or even it may have three parts. Suppose you are going to produce a wheel with a spoke, just like a car wheel is there now. So you have to produce that. In that case, you need three boxes. So intermediate section, if three boxes are needed, so whichever is in intermediate position is known as cheek. Okay, now this is known as cheek. And the top is known as scope, and at the bottom whichever is there, it is known as drag. So if three parts are there of the molding box, intermediate one is known as cheek, the one who is at the top is known as, and the one who is at the bottom is known as a drag. And whatever we are using to support from the bottom, this part, this is known as board, bottom board. Okay, so here it is also made up of wood. So as I told, it may be of metal, it may be of wood, or it may be of any material depending upon the application. It totally depends upon the application or the material that we are going to cast. Next one is the pattern. Pattern is very important part in this one, and it is called as the replica of the casting. Replica of the casting that we are going to produce. For example, suppose we are going to produce this rectangular shape. Okay, so exactly same dimension and shape pattern we need to produce. And this is used to produce the mold cavity, where we are going to pour the metal, and inside that it will solidify. So that's why it is known as negative of the part that we are going to produce, or the part which we are going to cast, or replica or duplicate of the part that we are going to produce. And second part is, this one is used. Now the material, it may be of any type of a material. It may be wood, as I told, depending upon the application. It may be metal or it may be plastic. That totally depend. Advantage and disadvantage of the material is associated. So it's totally based on the material that we are going to cast, as well as what is the volume of the product that we are going to produce. Suppose we want to use as a permanent pattern, so obviously we will make this with metal. We will not make this with wood. If we are making with wood, we know the life or durability will be very less. So depending upon the number of volume that we are going to produce, as well as depending upon the sophistication of the process, we can choose whether it may be of plastic, made up of plastic, it may be of metal, or it may be of wood. Okay. Third is parting line. Parting line, this is known as parting line. This is the intermediate or dividing line. This is the parting line. If scope is on the top and drag is at the bottom, so in between this line will be there. This line is known as parting line or dividing line. Next is molding sand. Molding sand means the sand which is used to prepare the mold. It has actually three sections. Three section means it is made up of three parts. One part will be, as I told, silica. Okay, another one will be water, and the third will be a binder, just like clay. Now what will be the proportion of all these three? That will totally depend on the product that we are going to produce. Okay, now, or the many properties are there of sand mold. One by one we will discuss in coming lectures. Today's lecture, we just have to know what is the meaning of molding sand. Molding sand means sand which is used to prepare the mold or mold cavity. Okay, and it is mixture of silica, water, moisture means water, and the clay as a binder. Okay, what will be its proportion? Generally 80 to 85% percentage will be of silica, and remaining 15% approximately will be the percentage of water in the clay, which will be used to prepare the mold cavity. Okay. Second one is another type of sand is also used, which is known as facing sand. So facing sand is generally sprinkled inside the mold cavity. The purpose of this one is just to whatever the product we are producing, for whatever product we are casting, the surface should be fine. That is the only purpose. That's why this facing sand is generally sprinkled inside section of the mold cavity. And next is core. Core is, it may be of any material depending upon the application, but generally it is made up of the sand, and it is used to produce the hollow section, cylindrical hollow section, or whatever the hollow sections during the casting we have to produce. For that we will use core. A special process is also there, which is known as centrifugal casting. With the help of that also we can produce the hollow sections or hollow casting, but that we'll discuss in coming lecture during the special casting processes, but that process is costly. So depending upon the cost and all, many aspects are there, but if you have to produce a hollow section, we can do with the help of core also, and generally it is made up of sand. Okay. Next one is pouring basin. Just see this, I have taken this diagram of gating system. Gating system means all the parts through which molten metal will pass one by one. So here molten metal will be poured. The first part, it's a funnel shaped, you can see just like a funnel. So funnel shaped structure you can see at the top. This is known as pouring basin. Basin in which molten metal is poured. Okay. And this is the second part. This is the second part, you can see here, this is known as a sprue. Okay, it's a truncated shape. We will see during the designing part why it is truncated, why its shape is not like this, why it is truncated. We will see in design section, but the fact here we just want to be aware of the terminology, the terms which will be repeatedly used in this process. So the second part through which molten metal will pass in this gating system is known as a sprue. So this is a passage between the pouring basin, and this section is known as a runner, which connects the gate and this sprue. So this passage is known as a runner. After that, this part is the gate. Gate is the intermediate section, okay, through which molten metal enters the mold cavity. This is the mold cavity inside which molten metal will enter. So this is the intermediate section between the runner. This is the runner and the mold cavity. After that, we have gate. This is the intermediate section, and finally the riser. This is probably the most important in all this part. Why I am telling this? Because it acts like a reservoir. Okay, na, reservoir of molten metal. So what happens, as I told at the starting also, in casting, phase is changing, material is changing from liquid state to solid state. So always there will be reduction in the volume. So we need to overcome that reduction in the volume. So this will be done by the riser. So different shapes are there of riser. What should be the requirement? How metal should solidify over there? All these things are very, very important, visibly covered in the section when we will start the design of the gating system. Okay. So for today lecture, this is all. Okay. In the next lecture, we will come up with some exciting part of this casting. Stay tuned. Okay. We will meet again. Thank you.